Hello and welcome to TN Academy. Today we are doing question 6, where we're given a function f at x is equal to ax plus b, where a and b are both integers, and we're given the function g at x, which is equal to x squared plus x plus 3, where x is all an element of real numbers. Now, for our question, it asked find two possible functions such that the composite function g at f at x is equal to 4x squared minus 14x plus 15. So to start, we will rewrite our function, we'll rewrite our composite function in simpler terms with regards to our functions. So if we rewrite our function in the simplest terms, we should be able to say that the composite function g at f at x should look something like f at x squared, as in our function g at x, the x is squared, plus x plus 3, so it'll be f at x squared plus f at x plus 3. Then when we substitute our function f at x, which is equal to ax plus b, we should get, after expanding and simplifying, we should get the function a squared x squared plus 2abx plus b squared plus ax plus b plus 3. And now what we have to do is compare this to the function that we are looking for variables so that our composite function satisfies it. So we have to compare it to the function 4x squared minus 14x plus 15. And the way that we will do this is we will look at our terms. We will compare like terms. So terms that contain x squared, terms that contain x, and terms that are constants, such as 15 and b squared, b, and the other constant 3. So as we begin to compare our coefficients, we will look at our own equation and the equation we are given. So in our equation, we can see that for our term x squared, we have the term a squared. And in the other equation, we have the term 4. So we can say that a squared should be equal to plus or minus 2, or a should be equal to root 4, again, which is plus or minus 2. Then for our x term, we have 2ab plus a, which should be equal to negative 14, as in the given equation. And lastly, for our constants, we have the terms b squared plus b plus 3 should be equal to 15. So now we have two scenarios that we must evaluate where and that is for our coefficient in front of the x squared term, where it can either be plus 2 or minus 2. So if we first evaluate for positive 2, we say we will let a equal 2, and then if we evaluate our first coefficient scenario, then a squared will indeed equal 4. So our first situation is satisfied, our first condition is satisfied, and we'll evaluate our second coefficient, where we have 2ab plus a is equal to negative 14. Then if we continue to collect like terms and simplify, we'll first substitute a, we'll get 4b plus 2 is equal to negative 14, and we can subtract 2 from both sides, so that 4b is equal to negative 16, and we'll find that b is equal to negative 4. And now that we have a and b, well, we only need b, but we can evaluate our final scenario and see if our condition is satisfied. So where we have b squared plus b plus 3 is equal to 15, where we'll then substitute b into our equation so that we see that negative 4 squared minus 4 plus 3 is indeed 15. So we can say this is one scenario where our equation is indeed satisfied, where a is equal to positive 2 and b is equal to negative 4. So our equation would look like f at x is equal to 2x minus 4. So now we will let a equal to negative 2 to evaluate our second scenario and all the existing conditions. And then for our second scenario, we let a equal negative 2. So then we can see that a squared equal to 4 is indeed satisfied, and then if we evaluate our second condition to solve for b, we substitute our a value in, and then we get negative 4b minus 2 is equal to negative 14. And we rearrange and solve for b so that it's equal to 3, and then if we evaluate our third condition, we see that it is indeed satisfied, so f at x is equal to negative 2x plus 3 is also a possible equation. So we'd have our two equations, and we could substitute them into our composite, into g at x, to find that our given equation here, 4x squared minus 14x plus 15, would be satisfied. And that's our answer to this question.